Video is on ways of expressing concentration unit. There are going to be 4 of them. However, before we start that, the reason we need to know these is we need to know the 4 ways of doing concentrations for something called colligative properties. It's something that depends solely on the concentration, but not the chemical identity. Okay, and the ones that we're going to be looking at are boiling point elevation, freezing point depression, and osmotic pressure. Those are the 3 that we're going to be looking at, those 3 there. And we need molality, we're going to need molarity, we're going to need mole fraction, and we're also going to look at mass percent. So we're going to do these one at a time. The first one is molarity. Now molarity we actually did in chapter 4, so you can go back to chapter 4. And this equation therefore is not given to you on the formula sheet because it was given to you on the formula sheet in 1211, so you need to know this, okay? That capital M is the moles of solute per liter of solution. So a solid, it doesn't matter what the volume is, a solid has the same molarity. This is a liquid, no matter what the volume, has the same molarity. But if I take solutes like helium gas and put them in different size containers, okay, this has the lowest concentration, this has more, and this has the most amount of helium gas. Or if I have a solution, which is what we're going to be dealing with, and have sodium chloride and water, okay, all 3 have equal volumes again, okay, so this has the least number of particles, so this has the least concentration, this has more than that, and this has the most or highest concentration of those 3 molarities, okay? And it's actually going to be true for all the concentration units, that's pretty much going to hold true. So the first problem is, again, I probably got these out of chapter 4, so you can go back to chapter 4 to look at these. And that's not the color pen I want. Okay, so I'm going to write out molarity only because of the fact that a large M, and we're going to get to molality, and molality is a small m, and large M and small m look the same if there's only one of them written. So I'm going to write out molarity. So molarity is N, which is the moles per unit volume, and it has to be in liters. So I'm going to shorten it to this formula of N over V. Okay, so we're going to start this the same way. It wants to know what the molarity is. If I have a mass of 29.0 grams, I have C2H5OH, and I have a volume of 545 milliliters. Okay, so it's asking for molarity, so I need the moles over volume, okay? And moles is the mass divided by molar mass, also not given to you since this is last semester, okay? So I have a mass, I need the molar mass. The molar mass is simply the number of atoms times the atomic weight. So I have carbon, and there's 2 carbon atoms, and each one is 12.05, plus I have 5 hydrogens, and so this is hydrogen, and it's 1.01, plus an oxygen, which is 1 times 16, or just 16, plus 1 more hydrogen, so 1 times 1.01, and when I add all those up together, I get 46.08 grams per mole. Okay, and I want molar masses to 2 decimal places. Okay, so do not round this to 46. I want it to be 46.08. It's a huge amount of rounding error if I start rounding these. So that's got a point right there. There we go. All right, so my N is my 29.0 divided by the 46.08 to give me 0.6293 moles. So I now have N. The volume has to be in liters. Now I'm going to go back to the way we did in Gen Chem. If you do it another way, that's fine. That 1 milliliter is 1 times 10 to the minus 3 liters. And that's 0.545 liters. Okay. Honestly, I just moved the decimal place 3 to the left. So I'm not going to count credit for showing this work. I will give you credit for having it in liters, however. So then I take my 0.6293 divided by my 0.545 liters, and I get 1.15, and it's a capital M is also the symbol for, or the units for this. Okay, and so this right here is my answer. Now, with these videos, the nice thing is that you can pause these videos and finish writing. Meanwhile, I'm going to go on. So I also suggest that you pause this video and try to do this problem on your own before I go through it. This is the best way to learn, is to practice. Okay, so this time, this problem wants to know what is the volume. So volume is my unknown. If I have a mass of 2.14 grams of sodium chloride, NaCl, and I have a molarity of 0.270 molar. So you need to recognize that this right here means molarity, okay? Because it's not going to necessarily say the word molar on there, okay? So again, the equation for molarity, which I'm going to write out, is N divided by V, okay? So I'm solving for V. I have a molarity, but I do not have N. So I need to find N first. And the same way we do this, I'm not going to spell out molar mass every time. This molar mass is 58.44 grams per mole, which is just 1 sodium and 1 chloride. Okay, so N is the 2.14 grams divided by the 58.44 to give me 0.03662 moles. Okay, so I have molarity, I have N, and I'm trying to find V. So I have 2.70 M. I have 0.03662, and I'm searching for the volume. So when my unknown is on the bottom, I have to get rid of the fraction first. So I'm going to multiply both sides by V. 2.70 times V is 0.03662. And then I divide both sides by 2.7 to get V by itself. So 0.03662 divided by 2.7. And I'm sorry, I've changed that. All right, this is nice thing is I can just erase that one there. This is actually 0.027. There we go. I just miswrote it. Okay. And when I do that, I get 0.136, but the units are in liters. It specifies in this one. If it doesn't specify, you can leave it in liters, but this one specifies this is milliliters. So I'm going to do the same conversion, that 1 times 10 to the minus 3 liters is 1 milliliter. And the reason I do it this way is because this is how the book sets it up in the first chapter. And so it's 136 milliliters. So 1, 2, 3. Okay. So you can check your answer. And for the next one, last problem for molarity. This time it wants to know what the mass is. Where's my cursor? So I have mass, and that's what I don't know. I have Ki, and I have a volume of 5.00 times 10 to the 2 milliliters. And I have a molarity of 2.80 molar. Okay. Again, molarity is N over V. I have molarity, I have volume, okay, so therefore I have 2.80 is N over, except for this needs to be in liters, sorry. So 1 milliliter is 1 times 10 to the minus 3 liters, and it's 0.500 liters. So 0.500 liters. I need to multiply both sides by that, so 2.80 times the 0.500 is equal to N. So N is equal to 1.4 moles. Okay, I don't care about the units as you go, I just tend to write them down. Okay, however, it doesn't want moles, it actually wants mass. So again, N is mass divided by molar mass. Okay, I have N, I want mass, so I need to find molar mass. So the molar mass of Ki is 166.00 grams per mole. Okay, and so I have 1.4 is mass divided by 166.00. So I need to multiply both sides by the 166, so 1.4 times 166 is equal to mass. And so I get mass is 232 grams. And yes, it was 0.4, but I only want I only need three significant figures for the answer. I also put down, just from habit, what it is that I measured the mass of. And so this is molarity. This is one of the 4 mass units we will be using, and the end of this video.